Okay, hi. Back here, back at it again. So when I got down to the carbon dioxide in the red blood cell, I even confused myself, but once I got into this section, it all made a lot more sense to me. So let's go over it like this in this chart. And I know this looks crazy right now, but once I explain it, it will make a lot more sense. So up here is the alveoli, and remember that that is where respiration is occurring in the lungs, is in the sacs that is diffusing the oxygen into the capillaries, right? The blood capillaries, and also diffusing carbon dioxide to get it out of the lungs for exhalation. So that kind of makes sense, right? Okay. So when we went over the oxygen, we're just going to do it again, and then we're going to jump over to carbon dioxide. Okay, so the transport of O2 in the body. So we bring in oxygen. It diffuses through the alveoli into the pulmonary capillaries. Okay, so we're in the pulmonary capillaries of the lungs, which is connected to our heart. And if we're bringing O2 in, and we're in the pulmonary capillaries, we're going to enter the heart through the left atrium. And they went over that in the cardiovascular unit and the blood vessel unit. So we won't go over it again. But so O2 is coming in. It's diffusing into the pulmonary capillaries, which is this structure right here. Kind of funny. So O2 is coming in at 1.5%. It's gonna dissolve in blood plasma, be transported as dissolved gas through the blood. So that's 1.5% of oxygen, dissolved gas. 98.5 is going to bind with oxygen to be oxyhemoglobin. So oxyhemoglobin, and remember, that's our fully saturated molecule right there. When oxyhemoglobin is coming from the pulmonary capillaries, it is 100% saturated. Okay, so 98%, 1.5. We go through the left atrium of the heart, out the aorta, down to the systemic capillaries, where we will then diffuse into the systemic cells that will perform cellular respiration. It's going to use up this oxygen. Okay, and then we're going to create a byproduct of carbon dioxide. Carbon dioxide will then diffuse into the systemic capillaries, but it will be going up deoxygenated. And so 70% of carbon dioxide is going to be carried through the blood by bicarbonate. Okay, and then 23% is going to bind with hemoglobin, which is what was happening in that blood cell in the previous video, is going to bind with hemoglobin, and it's going to be carried through the body as a molecule called carbaminohemoglobin. Jeez, carbaminohemoglobin. Okay, and then 7% of it is just going to enter into blood plasma as dissolved gas. Moving forward. So, we're going up. We enter into the right atrium of the heart through the superior vena cava, and then we're going to go into the lungs, right? So, boom, into right atrium, 7% is coming into the alveoli via dissolved gas. 23% of carbon dioxide is going to dissociate from hemoglobin and come into the alveoli as carbon dioxide, but that's happening at 23%. 70% will enter the alveoli as bicarbonate, and then we will expel it from the body. We will breathe it out. And we will just keep running this system over and over again. And as you see right here, this is external respiratory pulmonary gas exchange. So this is happening from the alveoli to the pulmonary capillaries. So that's when we're taking it in. Okay, pulmonary capillaries. Down here is going to be our internal respiratory system gas exchange. And this is happening between systemic capillaries and our systemic tissue cells for cellular respiration. Okay, I hope that makes more sense. Thanks. Pretty soon I'm going to go over how the nervous system helps us breathe. And then that should be my final video. And then I'll be taking my exam. So wish me luck. Bye.